Hello, my name is Vincent Choquet, and I am the team leader of the MangAdvisor team project for the final term project of natural language processing and information retrieval. Our team is composed of 3 French students with Fabien Colas, Maëva Le Cavalier, and me. For this presentation, I will first present the main idea of the project, then I will talk about the system development and the API. Then Maëva will explain the data managing system and the query system. Finally, Fabian will present the user interface and the exploiting results, and will conclude the presentation. So, what is MangAdvisor? Well, that's an application that suggests to users manga that they have not read yet. Our system knows which mangas the user has already read, and so the user can enter a query. Then our system will process this query and will give a list of unread mangas in output that responds to the query. All these projects was made with Python. Now we will see the system development of this project. I will talk about the Kitsu API, then Maëva will explain the data analyzing, and finally Fabien will present the user interface. So, in order to get our database of mangas, we use the Kitsu API. This API allows us to get manga attributes of all existing mangas with their title, synopsis, categories, etc. Then, with the sort option in the API call, we can get the most popular mangas, giving us a top of 1000 mangas. Our database is then stored in a .txt file and will be used in the data analyzing, which Maëva will tell you about now.
Okay, thank you, Vincent. So, hi, I'm Maëva, and now let's talk about data analyzing. First, we thought to do query by different ways. We'd like to do it by title, category, theme, keyword, or popularity. The big part was about themes, because Kitsu API doesn't give themes of manga. By themes, we thought about war, magical power, ninja, or whatever. So the idea to get themes of each manga was to do the LDA. For this, we needed to do the term document metrics and so to clear data. For this, we used MangAdvisor and Stemmer, lib that respectively put all verbs in the first person and reduced word to their root form. After, we made the metrics and then the LDA, but the result was not conclusive, so we gave up the idea. Today, our project can handle query by title, category, popularity, or keyword. All queries, except by popularity, uses Levenshtein distance to analyze the sentence. Levenshtein distance is very useful to measure the proximity of two words. Like this, user can enter a bad written word, and the program will still understand the wording of the user. The particularity of our project is that it takes into account the user preferences. Users have their own database inside our core, so our system knows which user likes which manga. This functionality allows us to make customized results. This means that if two different users do exactly the same query, if their tastes in manga are different, the results will be different. But how can we assure that? This is thanks to our handmade gate similar function. I'll explain it right after this slide. This functionality is also a key for another query request that I didn't speak of it yet. It is the guided query. This query will let MangAdvisor recommend you manga that you may like according to your taste. So, let's go back to the getSimilar function. It takes two parameters. One list of manga, which is the reference, as that means the ones we'll use to get similar manga to them, and a list of manga where this similar manga came from. Usually this list is all the database, but for category query, it can be only the manga that matches this category. Now, let's speak about the way it works. GetSimilar function calculates a score for each manga that indicates the degree of similarity between this manga and the one in the reference list. This score is the sum of category score, popularity score, and name score. So, for category, the more a manga has categories in common with the references, the higher will be its score. The popularity score is independent from the reference list. It just scales the rank over 1000 to a score over 20. And lane score is high if the number of volumes of the test manga is near the number of volumes of the reference manga. And so GetSimilar function sums all these scores, and then it sorts the array of all manga by score and returns the 10th best one. Now, I let Fabien speak about the user interface.
Okay, so I'm going to talk about the user interface. Basically, our goal to this application was to build something visual, something that will help the user. So as you can see on the left side, there is the terminal version, which is pretty basic. In this example, there is a searching by title, and yep, there is the list of manga, but it's quite all. But on the right side, there is the HTML page, which are much more visual and contain much more detail, such as the synopsis, the rank that are based on our manga database, the rating, which quite linked to the rank, and finally the likeness, which are individual. So here is Tim, and it's his own likeness. That depends on what kind of manga he's liking. So yep, I think it's pretty interesting thing to be more precise and more accurate. So it can give to the user much more experience, much more better experience. So yep, here is our sources. You can find us on GitHub. There is the API, documentation, and so on. So, okay, now let's talk about the demo of this project. So here, in this example, let's say maybe we can use the team, maybe. So, yep, here we are. So team is our users. Okay, so this is the program. You can search by title, category, popularity, and so on. This is all waiting here. This example, I will search by title. Yep, and now which title? In our program, we decided to implement something that will be helpful for the users. For example, I need to find out the manga Tokyo Ghoul, but yep, this is the right right spelling of his name. But if the user type something like this, it will work perfectly fine. So this is the final result. We needed to search Tokyo Ghoul, and this is the first that came up on the list. And yeah, this is the information that I talked earlier. And here you can see the likeness based on the user, which is Jim here. So yep, this is what we need. And to complete this example, we can use another user. Yep, thanks, bye-bye. We can, I don't know, maybe Susan, yep. So we are going to do this same thing. So search by title. I'm going to type Tokyo Ghoul then. And yep, so there is the Tokyo, of course, at the top of the list, but as you can see, there is many other manga that came up, and this is not the same score. So this list is based on what Susan likes, and this is pretty accurate. So yep, this is it for the title demo. I'm going now to present you the guided one. So let's keep it with Susan. So yep, if I type guided, so this is a student format searching, our application will just print out manga that will that Susan may like to based on what Susan is reading right now. So Susan may like in ordinary, based on these likeness, as you can see, 1980%. And what can you see? One Punch Man. So yep, this is our application, and this was our demo on it. Thank you for listening, and have a good day. Bye.